Hello and welcome to the XGENIA tutorial. In this session, we will discuss this reel strip configuration. Specifically, how this system configuration is implemented at the node level. What we are showing here is the overall implementation for the slot engine simulator functionalities. As you can see, there are many components here. We will focus on the core components, the reel strip configuration components, and the slot or game configuration components. Finally, we will explain the components regarding the simulation, which is also very important. For this video, we will focus on explaining the slot reel strip configuration. The component responsible for reel strip configuration is called direct reel strips. There are several steps to process the reel strip configuration. First is the random number generator. This component functions as the random seeding for the strip results. These are some of our parameters, such as the random seeds and the column size. If we break it down here, it receives the seed and the column size, the number of strips. Then we have the trigger button, the Generate Strip button. After triggering it, we generate an array of random numbers or random seeds for each reel in the reel strips to ensure randomness. Once that process is done, it triggers the next component, Generate Symbol Weight. This receives two important parameters: the number of symbols, meaning unique symbols, and the weight formula for determining the frequency of occurrence for each symbol in the reel strips. After calculating the weights for each symbol, it generates them here. This is a normalized version of the symbol weights, summing up to 100%. This represents the frequency ratio for the symbols. Low index symbols might have a more frequent occurrence. For example, using a scale of 1 to 10. Symbol 1 at index 0 has a 13% chance of occurrence, while symbol 10 at index 9 has a 7% chance. Next, it is processed by the reel strip generator node. This receives both the symbol weights and the generated random seeds from the previous nodes. It also calculates based on the column size. After considering all parameters, it generates the random reel strips with respect to the symbol weights received. For example, the generated reel strip will show that symbol 1 occurs more frequently than symbol 10. Therefore, the strips will contain more of symbols 1, 2, and 3. As you can see, symbols 1, 2, and 3 have higher occurrences. The same logic applies to the other columns, respecting the weight formula. After regenerating the reel strip, it goes to the component output, acting as the final output of the direct reel strips component. This can then be processed by other nodes. You may notice other nodes like free spins. You might wonder why it also needs to receive the reel strip data. When we enable free spin mode, there is a parameter called blocked reels. This parameter determines which columns we want to prevent from containing free spin symbols. For example, if we set the blocked reels to 0 and 4, we prevent the first and last columns from having the free spin symbol. This requires a modification of the reel strip itself. We take the reel strip and import it into the free spin symbol node, along with the free spin symbol and the blocked reel settings. This determines which reels are prevented from having free spin symbols, which requires this modification in the generator. And that's how the reel strip work. Thanks for watching. Get XGENIA for free today at xgenia.ai and start building smarter and faster than ever.